Hey guys, my name is Aditi and today I'll be teaching you how to find out the wavelength of a laser. The paper code for this is PH5P1. So the setup for this experiment is fairly simple. All you need is a clamp stand, a metal ruler, a laser and a long scale along with some twine like this for measurements. So essentially what is happening here is the laser is diffracting off of the millimeter rulings in the scale and is forming an interference pattern on the wall. To get the interference pattern, it's very important that the laser reaches this millimeter side of your metal ruler, not the centimeter side. You can adjust this by either using the leveling screws at the bottom of the laser over here, like these. And you can also adjust the tilt of the wooden board as well as the height of the clamp stand. Okay, so first to begin, we're going to make some markings. This is our central maxima. I'm going to put a pin over here at what I think is approximately the middle. The point above the central maxima is point 0. This is a very common mistake that students make. So as you're doing the experiment, I recommend writing down your value next to the point. Next, I'm going to take another pin for M1 and so on and so forth until say M7 or M8. So there are 8 pins here in total, one marking the central maxima and the other 7 marking the maxima that succeed that. It's very important to make sure all of your points are pinned beforehand because this is what we'll be using to take all our measurements to find the wavelength of laser. So to find the point X, we're going to move our stand until the laser directly hits the board. We will call this point X. And the distance between X and the laser is going to be the distance D, which we use in our calculations. Okay, so this is something important we have to do before we find the point X. We have to find the distance between the point where the laser diffracts off the metal scale to the screen. This distance is called L. So it's a little difficult for one person to do it. So the best way to do it would be to tie a thread around the wooden block towards the laser and then drag it here and make a marking on the thread. Now it's time to measure the pen mark you made on that side, the laser point on this side. So you'll be provided with 1 meter rule. You're going to use that to find the measurement. It'll be approximately 5 meters. Measured the heights as well. Okay, so just to recap, you first get the interference pattern on the screen. You mark your 8 points. It's important to remember that the central maxima is not point number 0. The line above your central maxima will be the spot with the number 0. So you mark all the way from 0 to point 8 and then you remove your ruler and you measure the direct reading from the laser onto your screen. This will be your point X. Now all your heights must be measured from 0 to X, 1 to X and so on and so forth all the way from 8 to X. So now when it comes to writing all of this in your lab record, the first column will contain your spot number. The second column has the distance measured between the spot and the point X. It is important to remember, so in the third column we are calculating Ym. It is important to remember that the value for h0 by 2 does not change. So the value that we are calculating here is h subscript m. It will be the same. So when you're calculating Ym, your hm will keep changing for values of m that is from 0 to 8. But it's important to remember that h0 by 2 will not change for any of these. After this, you're going to find out your ym square minus y0 square. And then ym square minus y0 square by m, where m is your spot number. It's easy to mistake m for the distance between the spots, that is hm, so do not make that mistake. After this, we find out the theoretical wavelength of laser using this formula. It should be at this order 625 into 10 power minus 9 meters or 625 nanometers. To calculate the wavelength graphically, we use the formula lambda is equal to d by 2l square into slope. Here you plot the graph for ym square minus y0 square versus m, where m is once again your spot number. You should get a straight line. The slope, once you calculate it, should be anywhere between 300 to 305. And once again, you should get a value close to 625 nanometers. To calculate the wavelength of laser, the result of the experiment should be around 625 nanometers graphically and experimentally. You can take the average for your final result as well.